Hi, geometry students. We're in lesson 12-4, volumes of prisms and cylinders. So we have a key concept here. It's the volume of a prism. Okay? And we're looking for the volume to be the base area. Okay? The base area here. Then just multiply by the height. Now, the base is anything that's a repetitive shape if we cut it. So prisms can be like this too. You could have a circular, which would be like a cylinder, okay? And the area of a circle would be the base. So we can find the area of a circle and then multiply it by the height, or the length in this case. Okay? So we're going to see different types of prisms in this presentation. So here's the first example. We're going to find the volume of the following prism. So in this case, our base actually would be this triangle. So when we say base, we don't mean actually has to be sitting on the base. It's just what's the repetitive shape. So if we cut this kind of like a loaf of bread, we're always going to see that triangle shape, okay, all the way back. So you can see the repetitive shape because it repeats in the back here too, this triangle. So the base is the triangle. So a area of a triangle is 1/2 the base, which is 10, times the height, which is, looks like they say it's 12. And that represents my B. So we're going to have area, right? Or volume, equals the area of the base times the height. Now, height doesn't mean it has to be standing up. So our height here actually is the 25. So this represents the B, and then we're going to multiply by the 25. And that should then give us the volume of this problem. So let's see what they got. So we have 1/2 10 times 12, and then times a height of 25. So we end up with a value of 1,500. And since everything was in centimeters, we have 1,500 cubic centimeters. Okay, let's look at the volume of the next prism. And even though this one's a check your progress, we will do it together. So, as you can see, the repetitive shape, okay, looks like this triangle shape because it also repeats all the way back, and you can see it back here in the back. So we could slice it and always see a triangle. So we have to figure out the area of the base. Well, we have 1/2 the base, which currently would be then A, times the height of 18. And that represents the B part of the equation. And then we're going to multiply by a height. Now remember, height doesn't have to mean going up. So this ends up being the height that we're going to use, or the depth, right, of that repetitive image, and that's going to be 15. So what's missing here, right, is the A. But we do have, looks like a right triangle, conveniently, and so we could use Pythagorean theorem to find A. So we're going to have 30 squared minus 18 squared. Okay, so you can all get your calculator out if you like to. So 30 squared, 900, minus my 18 squared, and we end up with 576, and then we take a square root. So we take a square root of 576, we end up with 24. And since that is my A, we could substitute the 24 in right here for the A. So we're going to take 1/2, we're going to multiply by 24, we're going to multiply by 18, and then we're going to multiply by 15. And I get 3,240 cubic inches. So our answer should be C. Okay, the next key concept is the volume of a cylinder. Okay, now a cylinder is kind of like a prism, except for the base, the B part, has a specific shape, and that shape is a circular shape. So we're still going to be using the BH formula, the area of the base times the height. This time the base has a specific equation, that would be pi r squared, which is the area of a circle. So to find the volume of a cylinder, we're going to multiply pi r squared, which is the area of the base, times the height. Now again, that cylinder could be on its side. So again, when we say height, all we mean is the repetitive, right, distance or the depth from this face here to the back face here. Same thing here. We would cut and we would have the same circular shape all the way up. Okay, so let's go ahead and see a problem. We're going to find the volume of the cylinder, and we're going to find it to the nearest tenth. Alright, so we're going to use volume equals base height, where the base, remember, is pi r squared, and then height. Well, my radius, it looks like, is 1.8 centimeters. So I'm going to take 1.8 and I'm going to square it. And then my height also is 1.8 centimeters. So it looks like we're going to have 1.8 cubed times pi. So pi times 1.8 cubed. Now, since we're rounding to the nearest tenth, I'm going to grab my calculator and take 1.8. I'm going to raise to the third power. I'm going to take, which is 5.832. So that would be like 5.832, but we still have the pi next to it. But since it does say to the nearest tenth, we're probably going to multiply 5.832 times pi, and I get 18.3 rounded to the nearest tenth. Alright, let's go ahead and using a calculator, 18.3. So with units, we'd have centimeters cubed. Alright, go ahead and find the volume of the next problem, and you can pause your video to see if you can get the answer right. Good, you got 1005.3, you are correct. So how do we get that? Well, we're going to take our pi r squared height. Well, what's my r? My r is 8. That's 64. Then we're multiplying 64 by 5, and then multiplying by approximately 3.14. In case you don't have a pi button on your calculator, you can use 3.14. So 3.14 multiplied by 64, multiplied by 5, and I get 1004.8. Right? Now, the reason why we're off a little bit is because I rounded the pi. Okay? Another approximation for pi is 22 divided by 7. It's kind of like a strange fraction. Okay, but if you have the pi button, that'd be better. So we would take 64 times 5, and I get 320. So our answer in terms of pi would be 320 pi, which would definitely be acceptable unless you were supposed to be following directions where it says the nearest tenth. If you have the pi button, let's take 320 and multiply by pi if you have a pi button on your calculator, and I do get 1005.3. Okay, so the next little principle says Cavallari's principle. If two solids have the same height and the same cross-sectional area at every level, then they have the same volume. It's like almost like a piece of clay, something that can be bendable. So these prisms all have the volume of base times height. So they have the same rectangular base and the same height, but it's kind of like just leaning it over. Okay? So we're going to find the volume of the oblique cylinder to the nearest tenth. So basically, think of this as a cylinder that maybe like it's made of jello, right? You can push it over. That's all. And so we're going to be finding it. There's no difference if this was standing straight up like this. Okay? The radius looks like it's 15. So remember, we're going to take pi radius squared. Okay, and that's the area of the base, and then we're going to multiply by 25. Okay, so if we take 15 squared and we multiply that by 25, we end up with 5,625 pi. And then if you multiply that 5625 by pi to get a decimal answer to the nearest tenth, we get 17,671.5. Okay, let's see what they say. And that would be cubic feet. $17,671.5 cubic feet. All right, go ahead and see if you can find the volume of the oblique cylinder to the nearest tenth, and you can pause your video. If you said 16,725.8, you got it correct. And all we're doing here is using the pi r squared. I lost my pen. Where? Oh, there it is. Oh, there it is. Sometimes it's so small you can't see it. So we have pi r squared multiplied by height. So we have pi. My r is 11. So I guess that'd be 121. And that's going to be multiplied by 44. So we're going to take 121 times 44 and then times pi. And we do get 16,725.83. So we'll round to the nearest tenth of 0.8.